Lesson 5.2 introduces something called slope-intercept form, which you talked about last year in pre-algebra also. This is based on linear equations. You already learned the first way to graph a linear equation in Chapter 4 when we were using t-charts and we were graphing different functions. So there are going to be 4 ways total to graph linear equations. First one is the t-chart, which you already know. Second one is slope-intercept form, and then the other 2 we'll talk about later. And again, you should remember this from last year. It's y equals mx plus b. And when you're looking at that, m means your slope. You're going to have to memorize this. B means your y-intercept. And then x and y are your variables, just like before. So you should always have an x and a y. But there should be a number in place of m and in place of b. One of the common mistakes I see is that students think that mx is your slope. So they end up taking whatever numbers here with x. Make sure you don't do that. M is your slope, x is your variable. So just remember, x is not part of the slope. Go ahead and copy example 1 down, and then hit play when you're ready. So just remember with y equals mx plus b form that m is your slope, b is your y-intercept, x and y are variables every time. You're going to have those as variables, and then you plug values for x in to find values for y, if you're talking about like a t-chart or something. And x is not part of the slope. Common mistake I see every year. If m was 2, I see students say slope is 2x. It's not. It's just the m, the coefficient in front of the x. And if there is no coefficient in front of x, then you have 1. So what you always have to look for with this is it needs to be in y equals mx plus b form. Notice I have y equals something x, and then this, remember, negative can be plus a negative, or subtraction can be plus a negative. So this is in slope-intercept form, y equals mx plus b, and your b is -5. So all you have to do here is say m, my slope, equals whatever the number, the coefficient in front of the x is, which is 3, and b, my y-intercept, equals -5. And you're done, because it was already in slope-intercept form. They're not always going to be that easy, because sometimes you're going to have to move things around and convert them to slope-intercept form, which we'll talk about later. But at this point, that's what you're looking for. Coefficient in front of x is my slope. Behind it, the number that's alone, is my y-intercept. Go ahead and write example 2 down, and if you want, you can try it on your own before you hit play again. When you go to write your equation here, you write an equation of a line, so it's a linear, with a slope of 3/8 and a y-intercept of 6. So you're thinking about that same idea. Y equals mx plus b. You're going to plug slope in for m. You're going to plug y-intercept in for b. If it's a negative, you always put subtraction here instead of plus. So you're just going to rewrite it. Y equals 3/8 x plus 6, and you're done. Copy down this part of this example. You want to make sure that your graph right here goes all the way to 4 on the x-axis and up to 3 on the y-axis for this example. Hit pause, finish that. If you have graph paper and you want to cut a piece of graph paper out for these, that always works really nicely too. So what they're going to do is they're going to ask you to write an equation based on a line that they give you on a graph. So you're going to be given a line, and I'm going to tell you to plot a point on 0, 2. So it should be on your y-axis right now. And then plot a point on 4, -1. get some kind of straight edge, and draw a line to connect those. If this was a problem you were given on your homework or in the book, they would already have the graph drawn out for you. So I didn't just make that up. I'm actually looking at a picture of a graph. You have to write an equation. You need to stop and think about the two things you need. You already know you have x and you know you have y. You need m and b. And you have to stop and think about what those are. So look at that for a minute and think about, is there a way for you to find slope? Hopefully you remember from lesson 5.1 there's actually two ways. You can count it out right off of the graph, or you can use that formula we talked about. So we'll use both ways just to try it out. And then your y-intercept is where it crosses the y-axis. So all you have to do is look where it crosses, and it crosses at 2. So right away you already know b equals 2. Now you need m. You have the point 0, 2, and you have the point 4, negative 1. If you're going to use your formula, let's go ahead and plug it into that formula we learned yesterday. M equals, remember, y2 minus y1, or y2 minus y1. It's up to you. I'm going to go ahead and say 2 minus a negative 1. Because I chose 2 first, I have to choose 0 first. So over 0, subtracting 4. Which ends up being 2 plus 1 over negative 4. And it becomes a negative 3/4. The negative can go with the top, the bottom, or right in the front. It doesn't matter. All that matters is that you have one negative here. So your answer, if you were to divide that into decimal form, would be negative. If you were to put a negative up here and here, actually should become positive. Now you would have y equals mx plus b. So you have your m and your b to fill in. The other way to look at this would have been to count out your slope. Remember, you always have to run right. So are you going to go up to run right, or are you going to go down to run right? You're going to end up going down, which means negative slope. So you go down and you count how many down you're going. So I'm going down 1. This isn't 1. It goes from here to here as 1, 2, 3. So I'm going down 3. Notice negative 3 right there. And then I'm going right 1, 2, 3, 4 to get to the next point. Right 4. So you would have ended up with the same slope that you did when you were talking about using the formula. And notice the slope is going down, so it should be negative. So you just write your final equation. Y equals negative 3/4 x plus b, or plus 2. Copy this down. Once you're done, hit play. We'll move on to the next example. It's just reviewing what we just went over. So you're going to find where the line crosses the y-axis to find your b. Then you're going to find slope using one of these two ways, and then you just plug it right back into the equation for m and b. Copy this example down. Once you're ready, hit play. I came back to another example just to talk to you about what this is asking for a minute before we go on to the example. What they're saying is, does the point they give you fall on the line that they gave you? I'm going to use this line as an example. If I was to give you the point, let's just estimate 2 and then 1/2 for my y. And if that was exactly correct, then it's probably actually really close to it, then that would fall on the line right there. Or if I look right here, 1 and about 1.5 is going to fall on the line. But if I gave you a point like negative 2, 0, it's going to fall somewhere else on the coordinate plane, like over here. It doesn't actually show up as one of the solutions on the line. So that's what they're talking to you about. They want you to evaluate to see, does this equation work when I use that point? Would it actually follow my line? And the way that you're going to do that is very simple. You're just going to plug it in. This is what value? That should be your x. This is your y. When you plug in 3 for x, you should get -5 once you evaluate this side of your equation. So you're just evaluating with these, and you're just saying yes or no at the end. X equals 3, y equals -5. I got these from the point, 3, -5. Now I'm just going to go plug it in, and I'm going to see if it balances. -5 equals -3 times 3 plus 4. -5 equals -9 plus 4. And -5 equals -5. It's like what you do when you check your equations to see if you got them right. So because this does balance out, then it is a point on the line. So you would say yes, or true, or whatever you want to say. That tells me that you know that that would fall on the graph if we were to graph that. It would fall right on the line on the graph. And then just make yourself a little note. If it didn't balance, then it isn't on the line. So that's how you're figuring it out. If it balances out here, then you know it's true. Copy what's on the left right here. It's talking about, again, what we just talked about right here. You're evaluating with your given x value, and when you plug in that x and y, it should balance out to equal the y value. And if it does, then that point does lie on that line. It is a solution. If it doesn't, then it's not a solution. Copy this down. Once you're ready, hit play. So one thing you want to get really good at noticing is when you look at these linear equations, which I know most of you are really good at recognizing a linear equation now. Remember, linear has an x and a y, not x squared, not absolute value of x, just x to the first power. We don't write to the first power because it's just x. But you want to get really good at looking at also the different types of linear equations you see. This is in y equals mx plus b form, slope-intercept form. The two easiest ways to graph when something is in slope-intercept form is either to use a t-chart, which you learned in chapter 4, or to use slope-intercept form to graph. And I'm going to go through that right now. So if you were ever stuck on something, or you were confused, or you felt like you made a mistake when you were graphing using what I'm going to show you now, you can always set up a t-chart, plug in values, and make sure those values match the line you came up with. So there's one easy way to check what you're going to do here. When it's in slope-intercept form, all you're going to have to do is look for your slope and look for your y-intercept. And it's basically a reverse of what we did when we wrote up the equation from a graph. So you're going to look for m. So m equals -5. And you're going to look for b. b equals 2. If you want to make that a fraction, it's over 1, because remember, slope is rise over run. So if we're looking at our slope here, we know we have rise over run, and because it's a negative, you should be going down, then right. Okay, you have to think of that every time with that. So go ahead and set up a graph. Again, graph paper makes this so much easier because you don't make mistakes with spacing. when you go to graph this, you're always going to start on your y-intercept because you know it crosses at a certain point when x is 0. And if you need to, think about that as a point. This point is when x is 0, y is 2. And notice if we plugged 0 into here, 0 times the negative 5 is 0, 0 plus 2 is 2. So your y-intercept is always going to have x is 0 and then whatever that intercept is. Plot that point first. So I'm going to go and I'm going to plot 0, 2, which is right here on this graph. Now you're just going to count out your slope. So because it's negative, I'm going down 5, right 1. So from here, not at the origin, I'm starting here from the point. That's why we always graph that first. 1, 2, 3, 4, 5, and then right 1, and then you put a dot. Okay, every year I see 2 mistakes. Students go 5 down and put a dot, and they go 1 over and put a dot, and then they're confused because they have a triangle. The other mistake that I see is students go back to the origin and start at the origin and count out their slope. It's not that. What you're doing is you're starting at your y-intercept, and then you're counting down or up, depending on if it's positive or negative, running right, and then putting another dot. And if you need more of them, you could go down even further and then put another dot. I typically recommend 3 dots at least before you draw your line. But because this graph was such a large space between, I'm going to stop at 2. But if you wanted to do a third, just so you kind of see how it would work, from here now I start and I count down 5 more. 1, 2, 3, 4, 5, and I go over 1 more. And notice a dot here would line up straight through with those 3. So go ahead and get a straight edge and draw your line in there, and then hit play, and I'll have stuff written on the left for you also. So you have a lot to write here. I'm going to go over it, then I'll wait a second, and then I'll move it up a little bit. First, you're making sure the equation is in y equals mx plus b form, which the one we were given in this example was. If it's not, you're going to convert it. That's going to be our next example. Second step, you're always going to start at your y-intercept, which is your b. It's what we talked about right here, where you put 0 in and then whatever your b was, and you plot that point on the y-axis. Third thing, you just count the rise over run and you start at the y-intercept, not at the origin. Be really careful with positives and negatives and connect the points. So I'm going to leave this for a minute and then I'll move it up. And once you connect the points, you should have a line. So go ahead and hit pause, finish copying that. Once you're ready, we'll get started on our last example. Copy this down. Once you're done copying this down, hit play, and we'll go over how to do this. Example 6 is graphing using slope-intercept form again. You're going to have to memorize what slope-intercept form is. It's pretty easy because slope, m, intercept, b, form. So y equals mx plus b. Notice this is not in slope-intercept form. Y would need to be alone. So when you see this and you're told to graph using slope-intercept form, you need to isolate y. And you're going to do that by following all the same rules that we've already been using when we've been solving equations. You're basically just solving for y. There's only one little thing you just have to be careful of because we haven't had much practice with it, and it's when you're dividing, if something's with the y, you need to make sure that every term on both sides gets divided. It's almost like a fraction buster. Think of a fraction buster when you're thinking of that division. And remember, division is like multiplying by a reciprocal. So very similar there because it's like a fraction buster but reverse. In order to isolate y, you need to move terms that aren't with the y first, then move the stuff that's with the y. So if you're looking at that, hopefully you all noticed you should move -6 first, or 6 first across as a -6. Don't accidentally combine terms that aren't alike. I end up with 3y equals a negative 2x minus 6. Those aren't like terms, so there's nothing I can do there. I'm still trying to isolate y. And this is what I was talking about right here. I have to divide every term by 3. There's 1, 2, 3. 3 terms, 3 divisions. This becomes a 1. I get y equals negative 2/3 x minus, and always simplify these when you can. 3 goes into 6 twice, so it's a whole number of 2 there, or an integer of 2. Remember, if it was 3 over 6, it would be 1/2. Be careful with that. Now you have slope-intercept form. All you're looking for, M and B. And you're going to graph it exactly like we graphed the other one. So if you want to hit pause and try it on your own, you can. Otherwise, you can follow along with me as I do it. We're going to start with our graph. And this one will be good because this one I can actually show you an example of going more than 2 points. Notice I'm using my lines to help me space correctly. If you're not using graph paper, that's a good idea. Oh, and you know what? I should have gone further here. Sorry. I'm going to go ahead and extend this. Okay. So M equals negative 2/3. So negative slope down to right 3. And if you need to, write it. Down to right 3. Because that might help you. B equals negative 2. Always keep the sign in front of that. I'm always going to start at B, which is 0, negative 2. So right there. And now I'm going to count down 2, right 3. Down 2, right 3. And that's about lined up. I'm a little off, so I'm going to move over a little more. Down 2, right 3. Again, graph paper makes that a lot easier. And then once I go to draw a line, I should have a nice straight line. I'm going to try it right now. When I connected my line, I have my 3 points lined up. So notice we started at our y-intercept, down 2, right 3, down 2, right 3, connect our points. If you needed more points to connect, once you have the idea of the way the pattern's going, you can actually go up 2 and left 3, and it should line up. Notice mine's a little bit off. It's because my spacing's off because I didn't use graph paper. If I'd used graph paper, it would have fallen right on 3 right there. So my spacing is off. These aren't going to be perfect, but if you're using graph paper, they're going to be pretty close to it. That's the end of today's lesson.